Morning, folks. Today we're going to be looking at piecewise functions. We're going to evaluate and graph and interpret the graphs of these piecewise functions. Hopefully you got a piece of paper and a pencil, and there's going to be points in this video where I'm going to stop and ask you to go ahead and try to do the question on our own. I suggest you pause it and actually try to do it on your own. Obviously I won't know if you do or don't, but it's going to really help you if you do that. All right, let's get started.
So here's the first thing for your notes. A piecewise function is multiple equations graphed on the same graph over different domains. You can pause this and write it down if you need to. Hopefully you remember that the domain is referring to all of the possible x values. Here we have a graph of a piecewise function. Notice that there are three distinct patterns on the graph. They are all lines, but they have different slopes. When we write a piecewise function, very often we start with f of x equals, and then there's a large bracket that lets us know that there's more than one rule to use. Next to each rule is a domain, or the x's for which we use that rule. The first rule is only used in this case as the x's or inputs are less than -2. So whenever we have an x value that's less than -2, we substitute that into the rule -x minus 5. You can see all the possible points graphed above in yellow. The second rule is used when the x's or the inputs are between 2 and -2. Whatever the x value is, in this case, a -1 comes out. In this case, no matter what I put in, if it's between -2 and 2, a -1 is going to come out. The third rule is only used when x is greater than 2. If I put an x value, an input, it's greater than 2, then I substitute it in for x. In this case, the rule is 3x minus 5. Here we're going to evaluate a piecewise function. Now, what that means is that generally we're going to find the output value when we have been given an input value. You should write the piecewise function down along with the problems you're about to do. You're going to need to be able to do this. Pause the video if you need to write this down. The first step in the problem like this is understanding the notation. This is called function notation. In A, you'll notice there's a g with a 4 inside the parentheses. And we would say that's g of 4. Now basically, it's just a shortcut of saying g is a function and the input value, or the x, is 4. So g of x is the output. So basically g of 4 means that the output of the function g when x is a 4 is equal to, and in this case we don't know what it's equal to, that's our job, we have to figure it out. If x, or the input value, is 4, then we must use the bottom rule because clearly that's bigger than the number 1. So then what we're going to do is we're going to substitute the 4 into the rule 3x plus 1 to find our output. When we do that, we find out that the output is going to be 13. So when we say g of 4 is equal to 13, basically we're saying is the output of this function when x equals 4 is equal to 13. You try B. First determine which rule to use, and then substitute it into that rule, and then lastly simplify. Hopefully you identified that with -3 is less than 1, so we're going to use the top rule. And then hopefully you took the rule 2x minus 1 and substituted x with a -3, and you got something like this, and you found out that the answer was going to be a -7. All right, go ahead now and try to do C. And remember to first look at the x and determine which rule to use, and then substitute it into the rule, and then simplify. The x value is 1, and that is less than or equal to 1, so we're using the top rule again. And when we substitute in the 1 into 2x minus 1, we find out that it equals 1. All right, let's look at another example. Here we have a piecewise function that's got 3 rules. Next to each rule are the x values that tell us when we can use those rules. In the first problem, A, you'll notice that there's a 2 in front of the f -4. Basically, this is saying find the output when x is equal to -4, and then multiply that output by 2. So here, let's take a look and see what that's going to look like. 4 is less than -2. So then I'm going to reuse the rule, -3 over 2, And then I'm going to substitute in the x of negative 4. And then I'm going to subtract 1. Well, this is the same thing as multiplying two fractions, and I could say negative 4 is over 1. So negative 3 times negative 4 is positive 12. So that becomes 12, and then 2 times 1 is 2. So that means 12, and we're still going to subtract 1. So 12 divided by 2 is 6, and 6 minus 1 is equal to 5. Now what we've got to do is we've got to say 2 times 5 is equal to, and then we find out that our answer is 10. Awesome. All right, now I want you to go ahead and try to do B on your own. We're trying to find f of 3, which means we want to find what the output is if the input is a 3. All right, awesome. Hopefully you did that. Hopefully you noticed that the input is a 3, so that's greater than 1, and we're going to have to use the bottom rule. And if we're going to use the bottom rule, basically that says that the output is always going to be a 3. Try C on your own. Right, thanks for doing that. Hopefully you noticed that the input is a 0, and that 0 is between negative 2 and 1. So we're going to be using the middle rule in this case. And if you substitute 0 for x in x plus 1, you're going to get 0 plus 1, or 1. And then hopefully you notice that there was a 3 out front of the f, which means we're going to multiply that by 3. So I'm hoping that you got that the answer for 3 is going to be 3. Go ahead now and take a look at D. The input value is a 1. Which rule should we use? Notice that none of the domains include the number 1. The middle rule is less than 1. The bottom rule says greater than 1. So then the answer to D is going to be no solution. There's no rule I can use. I can't find an answer to the question, what's the output when f equals 1? Next, we're going to be looking at evaluating a piecewise function if all you have is a graph. So here we've got a graph of the piecewise function that's listed down below. And what we're going to do is we're going to pretend for a second that we don't actually have the function. All we've got is the graph. So what I'm going to do is I'm going to cover up the function itself. All right, now that's gone. And what we're going to do is we're going to look at the problem, and it's basically the same thing we've been doing. The only difference between this evaluation question and the ones we did a minute ago is in this case there's only one question, but we're going to need to evaluate 3 times, and then we're going to have to add them or subtract them. So we're going to do them separately. Don't get too worried about this. It's not a big deal. I'm going to do the first one, and then you're going to do the next 2. So it's probably a good idea for you to take some notes here. The first one says that the input is a 4. Now, if I go along the x-axis to where x equals 4, and then go up to the function, and then figure out what that point is, I find out that when x equals 4, on this function, the y equals a 6. So you might want to take a minute and write down these steps. First, identify what our input value, in this case it was a 4, and then what I did was I went over to the x-axis and I found 4, and then I go up or down to the function's graph where x equals 4. In this case, I touch it at the point 4, 6. Now that point is the point, or the output. The input is a 4, the x, and the output is 6. So in this case, what I've found out is that f of 4 is 6. Okay, that takes care of the first one. Now I want you to do the second one. All right, great. Hopefully what you did was you came over here and you said, okay, the input is a 2, and then if I go to the x-axis where x is equal to 2 and I go up to the graph, I'm going to find this point right here that is 2, 4. And basically what that means is when x equals 2, y equals 4. So then what I did was I'm going to take that and replace that with f of 2, and then I'm going to multiply that by 4. And then 4 times 4 is 16. All right, that's the second one. Now I want you to go ahead and take a look at the third one. Okay, so this x value is negative, so we're going to go to the left side of the x-axis, and then we find the -5. In this case, we're going to go down to the graph. We find our point right here, and it is going to be -5, -2. That means that when we put an input of -5, the output is -2. So I'm going to take that -2, my output, and multiply that by -3. So I want you to go ahead now and figure out what our final answer is going to be. All right, awesome. Hopefully you did that and you found out that our answer is going to be 28. 6 plus 16 is 22. And then -3 times -2 is +6. So 22 plus 6 is going to be 28. Now you can also do the same thing by using Desmos to evaluate problems. So we're going to take a few minutes and go over how to do that. So don't worry, we're going to demonstrate this. Just kind of jot some of this down. Okay, hopefully you got that. So let's take a look here. We're going to try using this example and doing it in Desmos. So what I suggest you do right now is write down this problem, and it'll save you from flipping back and forth. So this is Desmos. I'm sure most of you have seen this already, but let's take a look at some of the basics. First, I'm going to go over here to this wrench over here and play with the settings for a second. You notice how it gives me all this stuff? Well, what I'm going to do is I'm going to get rid of the minor grid lines. They're the skinny little lines, and they're just annoying to me. And then the steps, I'm going to have it go by ones in this case. So I'm going to change both of these. And so then you see I got a graph kind of like what you would see on graph paper. And see, now I'm going to go over and I'm going to try to type in my piecewise function. I'm going to put each piece on a separate line. So the first piece is negative, and then its absolute value of 3x plus 4. So I go down to this little keyboard here, and then you'll see that I've got a bunch of different things I could use. But down here, you see where it says absolute value of a? I'm going to push that, and that's going to give me an absolute value bar. And then I'm going to put in 3x plus 4, and then I'm just going to scooch over because the other value bar is already there. And now I'm going to put in my domain with curly brackets. And again, I use the ones, I don't even, they're on here, but I'm going to use them on my keyboard. They're right next to the letter P. You're going to do Shift and curly bracket. And I'm going to say x is less than or equal to 1. That's down here in my little space, less than or equal to. And then put a 1. And then close up the curly bracket. All right, so that gives us our first graph. And you'll see it doesn't go on forever because it stops here when x is equal to 1. All right, awesome. Let's take a look at the second part. The second part is a quadratic. It's going to be 3x, and then I'm going to use the little triangle key, the caret key, above 6 on my keyboard. So Shift and then 6, and that'll put me up here as an exponent. And then I'm going to use my slide key, my arrow key, to get down into the regular out of the exponents. And then I'm going to put +2. And that's my other graph. Now the thing is, I've got to put in my domain. I'm going to use my curly brackets. And that's going to be x is greater than 1. And then close up my curly brackets. All right, so there is my piecewise function graph. And I can zoom in or out however I want to see more. And then if you recall A, the one is to evaluate g of 4. So all I'm going to do is keep in mind what that means. That means that x is equal to 4, and they want to find the output. I'm going to go over here, and I'm going to put in x is equal to 4. Now that's going to give me a vertical line that goes straight up at x equals 4, like we drew on our own graph. And so now all I've got to do is go up here and see where it meets. If you want to, you can use these zoom out buttons and see. Obviously it touches, you're like, well, how can I figure out what that number is? Well, all you got to do is click on it. And you see how it makes a dot right here? Then there's the point where they actually touch. 4, 50. So when the x is equal to 4, the y is equal to 50. And so the answer to g of 4, or what's the output when x equals 4, is going to be 50. That would give us the answer of 50. So now what I want you to do is I want you to do BNC. All right, awesome. Hopefully you did that and you got an answer of -5 for B. Okay, I think we're going to do C together, and I'm going to use Desmos just so we can review that. So let's get back to Desmos. As a matter of fact, I think I'm just going to do both B and C using Desmos while we've got it up here. So I'm going to go ahead, and B was g of negative 3. So I'm going to put in x is equal to negative 3. That gives me this vertical line right here. And you'll see that the point is negative 3, negative 5, which matches what we got algebraically. All right, so I'm going to go now and put in the last one. If I put in a 1. All right, now it appears like it touches both of these graphs. So let's take a look here. If I get on this red one and drag it along, you'll notice when I get to the bottom, it says when x equals 1, y equals negative 7. Awesome. Now I'm going to go up to the blue one, and I'm going to pull it down, and I'm going to go along. And in this case, when I get to the 1, it says it's undefined. And you notice how it's like an open circle instead of a solid dot? All right, it doesn't include that value, and that's why there's no answer there. So our answer, when x is equal to 1, would be negative 7. So then that would give us our final value of negative 7.
All right, I appreciate you paying attention and trying to do this with me. I hope you have a great day.